Welcome to Kitchen Chemistry with Mr. Gridley. We are in the summer of 2020 and are knee-deep in COVID. We want to make sure we're well protected. If we are doing Zoom videos at this point, I don't believe anyone has caught COVID as a result of watching a Zoom video. So at this point, we're going to take off our masks. So, thanks again for being here. You can see the elements that are listed on the periodic table. Today we're going to learn and we're going to take a look at some of the elements if you are stuck at home and you can't get a chance to actually see some of the elements and their behaviors. Let's start off with aluminum, and the symbol is Al and the name is aluminum. We want to know the names and symbols very well and very quickly and easily, so we'll start off with some aluminum foil. We've seen aluminum foil before. It's thin, it's shiny, okay? It reflects light very well. So here's aluminum foil, the symbol is Al. Now here is a baseball bat, okay? This baseball bat is lightweight and it is made out of aluminum. We also have pop cans. Pop cans are also made out of aluminum. So the one thing we're seeing is that if the aluminum comes in different shapes, it is still the same element, even though there might be different shapes. We also have a ground up aluminum here. We can take a look and see inside there. These are pieces or shavings of aluminum. Again, it doesn't matter what kind of shape it's in. It's the element's identity that's important. So here's some aluminum. We also can see aluminum here. Okay, there are many uses for aluminum. It's lightweight. It conducts electricity and heat pretty well. Another object, here's a walker from my father, okay, very lightweight and pretty sturdy as well. I have a small little piece of aluminum here as well as a small sample. So aluminum is a shiny metal, okay, it's one of our first elements listed. We will not do all the elements, but we will do a fair number of them. Now, one thing we also have here is a Geiger counter, okay? Our Geiger counter looks like this, okay? We will always hear about maybe 10 clicks every 30 seconds or so. That just is normal background radiation. So we always hear a couple of clicks, but we want to see, is aluminum radioactive? And we try to bring this nearby here and we say, well, we're getting a few clicks, but nothing significant, okay? So aluminum is not radioactive. We also have a magnet. Let's go see if aluminum is magnetic. Turn off the Geiger counter and see if we can pick up the aluminum with the magnet. Aluminum is not magnetic. So oftentimes people think that all elements and all metals are magnetic, but aluminum is not. Let's continue on with the next element we have, which is carbon. Carbon, the basis of life. Carbon, C, okay, we want to be able to identify the name and symbol quickly and easily. Sometimes you'll see the name first, sometimes you'll see the symbol first, but you should know them quickly and easily. So carbon, here's some carbon, it's black. It looks like burnt wood, and burnt wood is exactly that, it is carbon. We sometimes talk about writing with carbon, and if I write on the back of this, I can say hi, okay? So carbon is what's inside of our pencils. It comes as graphite, it can come as sort of a carbon black powder. It's the element of life. The symbol of it is C, and here is a good picture of some carbon. You can also look at your pencils. Your pencils are almost exclusively made from graphite, which is carbon. Our next element is calcium, and the symbol for calcium is, our next one is copper, okay? Copper looks like this. It's a shiny metal. Here's some little beads of copper. It can also come in a number of other forms. So here's some shiny metal, and the outside of this is copper. We also can have nails of copper, okay? And finally, the last thing we might have here, two more things, okay? Probably the most important thing is copper wire, all right? All of our houses are connected to copper wire, and that copper wire is connected to a power source, and generator that makes electricity. So this is what's inside of all of those wires inside of our house. It can also come in sheets. So we have a sheet of copper wire, looks like this, all right? So here's a piece of copper wire inside, and let's go test to see if that's magnetic as well. So here's our nail. Let's see if we can pick it up. We can't really pick up that nail, okay, with this. And here's some other copper as well. And we're not getting any kind of connection at all, all right? Again, even with our copper wire, we're not getting anything. So copper, element Cu, is also a metal. It's shiny, great conductor of electricity, but not magnetic. Now let's try this paintbrush. If I go ahead and try to pick up the paintbrush, okay, the paintbrush for sure has shiny copper on it, but because it's magnetic, it probably contains another metal, probably iron. If we look and see our symbol for copper, Cu is our symbol for copper. It is not Co. Co is cobalt, which I don't have any samples of. Cu is copper, coming from the Latin name coprum. People remember this by saying, see you later, copper. So if you were to go ahead and be a little less respectful to a police officer, you might call them a copper. And if you said, see you later, copper, okay, you might help remember the symbol for copper. So there's some samples of copper. Our next one is gold, okay? Gold's down over here on the periodic table. It's a transition metal. Where's a sample of gold? I just took this from this ring. I had to take it off. It's a little bit tricky to take off. But here's a gold wedding band. This gold wedding band came from my great-grandfather, okay? And it was just as shiny and just as nice as it was when he wore it many, many years ago. We also have some other examples of some gold, okay, on the edges of the plates. This is gold as well, all right? These are our wedding plates we got. These are very nice. Here's another one that's also made out of gold. Inside of a lot of electronics, you're also going to find gold as well. It's a very, very thin layer of gold. Gold is a great conductor of electricity. It's even better than copper. Copper and silver are in the same, they're in the same column. They're great conductors of electricity. They are considered precious metals. The symbol for gold is Au. Some people might remember this by saying gold. Oh. So, symbol for gold is our next one. Our next one is a very common element, iron, somewhere about here. And again, the name and symbol don't match, all right? The symbol for iron is Fe, coming from the Latin ferrum. Iron's been around for a long, long time. And if we look for some samples of iron, okay, here is some little tiny pieces of iron. We look inside and see it. We can see the reddish rust that's common, all right? Once any kind of iron reacts with air and it takes some time, it oxidizes, okay? So what the stuff we're seeing on top of the iron is called iron oxide. That's the rust, all right? So that's a good sample there. We didn't test our gold, okay, to see if the gold is magnetic, but gold is not magnetic. However, iron is. Let's go get some samples of some iron. The symbol for iron is Fe. And if we take our sample of iron, and look, there we are, okay? Fe is a symbol for iron. There we are. Iron is magnetic. It is very common, and things that are magnetic often contain iron. Many household items, okay, like this, are magnetic because there's going to be some iron in there, okay? There are three elements that are magnetic: iron, cobalt, nickel. They're all located right about here. So iron, cobalt, nickel, FeCO(Ni), FeCO(Ni). Those are the three elements that are magnetic, okay? Copper is not magnetic, but this is only a thin layer of copper, and the rest of it is iron probably, because iron is very cheap. Now, iron can be found just about anywhere, all right? You're gonna find things, okay? So this looks like a tin can, but yet what happens is it's magnetic. It probably contains some iron, all right? Here's some shiny looking, it looks like silver. What is it? No, okay? It's iron probably, because it's magnetic. Here is also a paper clip containing some iron. So iron is pretty much found in a lot of places. It's very cheap and easy to extract. We produce a lot of iron in this country, and it's used as because it's very strong, and it tends to corrode very, very slowly. Our next element is lead, Pb. So here's lead, Pb, and let's get some samples of lead. So these are some fishing lures, all right? Lead is a common item used for fishing lures, and we can see it's pretty heavy. It's one of the heavier elements. It's sort of down lower on the periodic table. Lead comes from the Latin, the Pb symbol comes from the Latin plumbum. Sounds like plumbing, and we did use lead oftentimes in plumbing. We don't as much anymore. We often talk about lead pencils. We don't like to use pencils very much anymore, but we can also write with lead, okay? So this thin layer of lead will come off when writing. As a result, both carbon and silicon are similar, so they're going to be in the same column, all right? So carbon and lead are going to be in the same column. They're similar in the fact that they both can write very easily, and the thin layer of lead will come rushing off. Lead can come like this. It can also come in big sheets like this. All right, we can bend it. So this is another sample of lead. After handling lead, most people like to go ahead and wash their hands. All right? So here's another big sample of lead. Okay, it's always a good idea to wash your hands because lead can come off relatively easily. Let's check to see if lead is magnetic. Is lead magnetic? Nope, okay. Our lead is not magnetic. Here's another one. All right. Again, lead is a little bit more of a grayish dull metal. It's less shiny than a lot of our other substances, okay? We happen to have an iron nail here. Oh, and it's magnetic as well. All right, you can see the rust. So this is a good example of iron. I also have an old shot put ball here as well. We can see the rust and everything else, all right? But another substance that's also made out of iron that I didn't show you earlier, that is a nice magnetic sample of iron. The iron has oxidized, so this is iron oxide. Anything that looks sort of reddish, that's going to be iron oxide that we're seeing. What is our next element? Magnesium, Mg. So here's some magnesium. It comes oftentimes as sort of as a spool like this. All right, we can tear off the pieces relatively easily. It's okay to handle magnesium, all right? So here are some pieces. We can rip it with our fingers like this and tear off a little tiny piece of it. We will do a fair amount of chemistry with magnesium. It's a shiny metal. It comes like this. It can also come ripped up into tiny small pieces. It can also come as a powder. So here's some magnesium. We test magnesium, a shiny metal. Again, it's not magnetic. How come? Only 3 elements are magnetic. Iron, cobalt, and nickel, Fe, Co, Ni. Those are the 3 elements that are magnetic. Let's continue. Oh, here's some more sample of magnesium. Just tiny little ground up pieces. Our next element is phosphorus. Phosphorus, the symbol is P. So phosphorus, P, name and symbol. You want to memorize these. On normal matches, okay, a regular match, the tip of the match is red. The tip of this match is white. The tip of this match is phosphorus. The white is phosphorus. The red is also phosphorus. So both the red stuff at the end of the match and the white stuff at the end of the match are both phosphorus, okay? It's a little bit weird that phosphorus can come in 2 different colors. There's a special name for that. That's not important for today, okay? The white tipped ones are strike anywhere matches. If you're going camping, okay, these are great because they're relatively easily to strike, okay? You can strike them off of here, but you can strike them off of other sources as well. So white stuff and red stuff on the end of matches are phosphorus. It's pretty darn flammable. Silver is our next element. So where's our silver? Silver, the name and symbol also don't match. So Ag is silver. And there's our name and symbol, okay? This is often confused with gold. Ag is silver and Au is gold. Oh, all right. So what do we have? We do have some samples of some silver. Let me get our samples of silver. Probably the easiest way to see silver is real silverware, okay? So this is silverware, all right? One way you know it's silver is it's been sitting inside of the kitchen, not in the normal kitchen, but in the special drawers, and it tends to corrode, okay? We call this tarnish, all right? So silver, it looks like this, but again, we can see sometimes it will tarnish a little bit. There we are. Silver has great antimicrobial properties, as well as being a precious metal. It's antimicrobial, meaning that it will fight off some bacteria. So some people are experimenting with silver as an antimicrobial agent. Our next one is sulfur. Sulfur is yellow, relatively lightweight up here near the top, non-metal, all right? And also non-magnetic, okay? We want to waft the sulfur towards us, okay? Sulfur for sure has a smell. Here's a larger sample of sulfur. Again, a bright yellow color, and it does have a smell, all right? We don't want to go poke our nose like that. We waft the fumes towards us, okay? And sulfur does have that bad rotten egg smell. So there's some of our sulfur. The symbol for sulfur is just S. That's been around for a while, and so the name and symbol do match. Sulfur is just S. Our last one that we have to share today is some zinc. And I have some zinc powder, just some small amount of zinc powder and a piece of zinc, okay? Zinc can come in a wide variety of pieces. It can come in as little tiny granules. It can come as chunks as well. So zinc is Zn, relatively lightweight metal. It is also not magnetic as well. So that's one that's also not magnetic. I don't have the name and symbol for it, but we do have some calcium today, okay? So calcium is just Ca, and here's some sample of calcium. Now calcium by itself, okay, we think of calcium as being inside of our foods and everything else, but pure calcium, okay, looks like a shiny metal. I'm gonna get a little bit of calcium out. There we go, okay. And we get it out, we put it on here, we take a look at it. Here's our calcium, okay, just a small piece of it. Now pure calcium, okay, is a shiny metal. It's sort of a dullish, sort of whitish metal. Well, what calcium does that most other substances don't do is it tends to react with water. So I have a sample of water here, and looks like it got some dye in there too, okay? A little bit colored so you can see the water a little bit. But calcium inside of our bodies is not pure calcium. It is calcium carbonate. It's a compound of calcium, okay? Pure calcium sinks to the bottom of a container, okay? But it reacts. It produces bubbles when you mix it with water, okay? If you have milk or something else, it doesn't react with water, all right? Pure calcium reacts with water and starts to produce some bubbles, all right? So please be careful, okay? Compounds that contain calcium are not the same thing as calcium by itself. Thank you very much. It's been about 12 minutes, and we're going to stop our video now. Welcome to Backyard Chemistry again. Here's one element we didn't show earlier, and this element is iodine. It is pure iodine. And as you can see, I'm outside today rather than inside. Iodine is notorious for causing stains. Very, very bad stains. So let's go take a look at the iodine. I poured a little tiny bit out here, and we can see the iodine. It looks sort of somewhat shiny-ish. Okay, the crystals. Now, you might have heard of a tincture of iodine, which is very, very different than this iodine. Okay, this is pure elemental iodine. It does not dissolve in water. It does react with a lot of things. And I'm outside today because I don't want to go ahead and put a stain on the countertops. When you talk about iodine in medicine, you're not talking about this kind of pure iodine, you're talking about a mixture of iodine and something else, as well as the fact that the iodine in medicine is often a compound of iodine rather than just simply the iodine by itself. But iodine is highly reactive. It's great at killing bacteria. So if you're doing a surgery site, they'll use either the mixture of iodine or a compound of iodine to help make sure any kind of surgical site is clean. Hello, it's Mr. Gridley again with Kitchen Chemistry. We're looking at some additional samples of elements. Here we have some bismuth. It's a small amount of bismuth. There's a container. That tiny little bit of metal is bismuth. And we can see we have our Geiger counter there. We're not getting any readings on that. Our next one down is cadmium. Here's a sample of cadmium. It's a little tiny piece there. Sometimes we have just super small sample sizes of things. And we'll go check to see our magnet. Nope, cadmium is not magnetic. Go back to our bismuth. Bismuth is also not magnetic. We'll go down to our cobalt. So this is a sample of cobalt. Once again, it's a little ball. It's not a magnet. It's not radioactive, but it is in the shape of a ball. We'll bring a magnet near there. Oh, and we do have one that is magnetic. So we've talked about cobalt being magnetic before. Cobalt is magnetic. Let's go back up over here to our silicon. We have a larger sample of silicon. And there we are. Silicon Si looks a little bit shiny-ish. Then we're going to go to some silver. Now in this case, I don't have silverware. I just have some tiny flakes of some silver. The container that we have there is filled up with some finely ground up silver. We actually do chemical reactions in which we produce silver, pure silver, but it comes as sort of a powder. We'll check our Geiger counter reading for silicon. Once again, nothing. And our Geiger counter reading for silver, and nothing as well. And then our next element down is germanium. Germanium, once again, we check Geiger counter readings. We're not getting anything. We'll turn that off. Notice germanium is sort of a powder. It's a black powder. It might remind you of another element that you should put it in the same column as. We have two special guests. Number one is we do have a small sample of mercury. So here it is. It's a liquid that's sitting at the bottom. It's moving around. It's a liquid at room temperature. So here is a sample of mercury. The symbol is Hg. We then have a sample of strontium, and then we have a lead container. Now this strontium is a special kind of strontium. It is strontium 90. Let's go check and see our strontium 90. We'll turn this on. And this is highly radioactive. So let's go take a look at the strontium 90 briefly. This is just a lid. There's a shiny metal. We can see it's highly radioactive. So we very quickly put it back inside of the lead container. We put our label back on there that fell off. And then we seal it up with our lead container. Why lead? Because lead is great at blocking some of the radiation. So that strontium 90 for sure was radioactive, but the lead container blocks a lot of that radiation. And then our last one we have here is what looks like a piece of nickel. So I took this out. I said, aha, that sure does not look like nickel to me. So what I did is I went ahead, brought my Geiger counter, tested it to see I'm not getting any radiation. And then we know that nickel is magnetic, but I'm not getting anything from my magnet. I tried to test this. I said, well, can I bend it? And I could bend it pretty easily. It's shiny, but not super shiny. This is most likely going to be tin. So this unfortunately got put into a wrong label. The label says nickel, but it is not nickel. It is most likely tin. So we have to be very careful about putting things in the right container and labeling them. But again, sometimes you have to use a little bit of common sense about what the elements look like. Hope you enjoyed a few more elements for kitchen chemistry.